All right, I think we have a good crowd so far. Paige, I'm going to start.
Okay, yeah, for sure.
Hi, everyone. Welcome to another SCLAA Thought Leadership webinar. My name is Faraz Bidar. I am the Vice President of WIC-TAS Division, as well as your host for today's session. Today's topic is AI and the future of warehouse labor management, presented by Paige Wilkinson. Hi, Paige, and welcome.
Hi, Faraz. Thank you so much. So yeah, welcome everyone to today's session on AI and the future of warehouse labor management. So over the course of this presentation, we're really just going to start out with a few key concepts associated with artificial intelligence or AI. And then we're going to spend most of today's presentation diving into the topic at hand, which is really using that new technology to really optimize your warehouse labor management. And this is going to be divided specifically into three distinct sections. So the first being orchestrating work, then planning labor, and finally performance coaching. I am going to be using a few different companies as examples as we talk through each of these different areas for optimization. I do want to emphasize it's not an endorsement of any of these particular companies. I'm really just trying to use them as examples and look kind of at where the industry is headed and the ways in which AI is already being used in this space. But before we jump into the topic at hand, just a little bit more about my background as well as Softion, which is the company that I'm coming from. So I spent close to a decade of my career boots on the ground in warehouses. So first in industrial supply distribution, and then in furniture manufacture and retail, in operational consulting and VP of Ops roles, before transitioning to software, first at Oracle and then at NetSuite. And then I have landed at Softion, where I am our director of solutions consulting or pre-sales, which is basically any demos that you might get of our software would come from my team. But as far as Softion as a company, for those who are unfamiliar, Softion is a vendor of warehouse management systems. So we are a global leader in WMS. So we've been optimizing supply chains globally for over 25 years. And we've actually recently expanded into Australia in terms of establishing an office in Melbourne as of fall of last year. So really excited to be working more with Australian companies where we can really see how we can optimize your supply chain solutions in a variety of different ways. So today's session in particular is going to be more of a broader industry trends and leveraging AI applications in labor management systems or LMS. But our experience across these global supply chains really gives us valuable insight into these real world challenges facing your operations. And personally, as far as my career experience, so starting with warehouse operations through to Softion, I like to think that my entire career has been based around improving warehouse operations, which is why I'm so excited to walk you all through these technology advancements that can really enable your teams to optimize your warehouse labor, creating happier, more effective employees. And with that, let's head into today's topic. Okay, so our first stage of today's presentation is really to solve the problem of definitions. So in the modern age of the AI buzzword, what do we actually mean when we say AI? And I will emphasize that this is not a deep dive on AI. I'm not an AI professional. This is really just about level setting on some key concepts before we dive into its applications in warehouse labor. But when we open the Pandora's box of AI, a dizzying amount of information falls out. People use the same terms to refer to different things, and it can be really difficult to kind of get your bearings in what we mean when we're talking about AI. So in today's presentation, we're going to simplify. Our first kind of umbrella term that's going to feed into the rest of today's discussions is just artificial intelligence or AI. And here we're taking kind of the broadest definition of that term, which is any techniques that equip computers to emulate human behavior. So enabling them to learn, make decisions, recognize patterns, and solve complex problems in a manner similar to human intelligence. So that's going to be from algorithmic machine learning to that more ChatGPT chatbot type function. Kind of everything is going to go under that umbrella. And today, we're going to be looking at 4 different types of AI modeling. So specifically causal, generative, predictive, and vision AI. But let's take each of those one at a time, using traffic to kind of explain what each of these model types can do, just leveraging different data sets. So our first term is going to be predictive AI. So a purely predictive AI model is just looking at correlations in historical data. So different trends across that historical information. So if we think about traffic, it's looking at data associated with changes due to rush hour or weather patterns. And it's going to use those trends to predict the length of time it takes you to get to your destination. So maybe that it's going to take 30 minutes on average for you to get from point A to point B. Our second model type is going to be causal AI. In a purely causal AI model, we're not looking at historical information like predictive, we're really just drilling down into root cause analysis. So looking at dependency and causality within the data set. So if there's a crash on the freeway, how is this going to impact our commute time? The best versions of the labor management systems that we'll see in today's presentation are actually going to combine those 2 different AI modeling techniques. So leveraging both that historical trend information and that root cause analysis for more intelligent recommendations. So given that there is a crash on the freeway, if we take an alternate route, it's going to save us 15 minutes. Beyond these kind of more data-driven for predictive and causal AI structures, then we have generative AI. This is what in today's kind of ChatGPT environment people often mean when they say AI, which is that kind of chatbot function. But really a generative AI is just something where you can use natural language and every input you get is going to result in a different output even with the same question. That's kind of how you transact with those data sets. So as an example, maybe we ask our Gen AI, what's the best way to tell a customer that we're going to be late due to traffic? And it's going to tell us, maybe don't actually tell them that it's due to traffic. Maybe kind of be more action oriented and say, sorry, I'm going to be 15 minutes later due to some unexpected circumstance. I'll be there as soon as I can. Then in our final AI modeling technique that we'll look at in today's presentation, we have computer vision or vision AI. So vision AI is just an AI model that translates visual information into usable data. So it's often going to be paired with other modeling techniques for leveraging that data. But it can be used in a variety of different ways. So as a real world example, on the Autobahn, the highway in Germany, they actually use vision AI to look at the volume of cars and their speeds on the Autobahn to dynamically set intelligent speed limits for the ideal speed limit on the various sectors of the Autobahn. And we can also use vision AI in things like navigation apps, where if we have camera or video imagery that we can leverage with vision AI, we can have more intelligent recommendations as for how long it's going to take you to get from point A to point B, and more intelligent information associated with that traffic level. But so now that we have level set on the different AI terms and models that we'll be looking at in today's presentation, let's take a step back and look at the core of today's presentation, which is warehouse labor, and why this is an area that is rife for optimization. So first of all, and this is not unique to Australia, but is kind of a global phenomenon. But there is, in looking at specifically Australian labor market analysis, logistics and warehousing is seeing some significant warehouse challenges. So there are high demand for warehouses employees, but there isn't enough supply of those employees. And so there are those tight conditions. It's difficult to attract talent, which means that it translates into being costly to attract talent. And then meanwhile, Australia's e-commerce growth continues to transform warehouse operations. And the Australian market is experiencing similar pressures to global trends, which with consumers expecting faster delivery times and more flexible fulfillment options, all while warehouse operators struggle to find and retain qualified workers. So this puts tremendous pressure on the warehousing industry through increased omni-channel order orchestration and more complexity in customer requirements with constrained human labor to complete those tasks. And then finally, we have traditional management limitations. So things like manual scheduling, reactive performance tracking, and limiting workforce optimization, which means that you can't really optimize the labor that you do have in your warehouse environment. So as the warehousing sector seeks to address these challenges and solve labor inefficiencies, AI can be a really effective tool in a variety of sectors to improve labor productivity and to maximize your available resources. So in this current environment, AI can help drive optimal productivity in your warehouse in a variety of different ways. So the first being leveraging warehouse execution systems to orchestrate human labor with increased automation. So using AI to create or suggest labor adjustments. Then we have predictive analytics, so using AI for labor planning, scheduling, and automated labor adjustments in the same day capacity. And then finally, using AI for real-time performance management with suggested training and coaching to improve your workforce. And we'll take each of these on its own, starting with leveraging warehouse execution systems to orchestrate human labor with automation to better orchestrate work in the warehouse holistically. So as warehouse operations have sought to increase efficiency rather than headcount, thus far, they've increasingly turned to material handling equipment automation. However, as the CTO of Softion likes to say, integration is easy, orchestration is hard. So in an increasingly automated warehouse environment, lots of the warehousing software has created interfaces that integrate with various cobots, goods to person, and AMRs, but very few of them can orchestrate that work across human labor and automation, leveraging what is referred to as a warehouse execution system. And it's within this framework that AI can really be leveraged to further this orchestration. So we can think of a warehouse execution system, or WES, as adaptive cruise control in a car, so keeping with our traffic theme. So it's the orchestration layer that's really going to sit on top of the warehouse management system. And in the best iterations of these systems, they allow your team to see upward from the floor, so things like lane full messages in your conveyor, as well as downward to include things like order back pressure, team attendance, or SLAs. And of this burgeoning type of software, many of them still rely on rules engine-based actions. But this is an area ripe for opportunity to incorporate AI in a couple different ways. So the first of which is using a combined causal predictive model to create trends and projections within the warehouse. So if all 10 items are staged on the conveyor at once from picking, will this back up pack station 1? Or when a team member is gone in replenishment, will this reduce efficiency by 20% in that department? The second of which is to leverage the expectations of the causal predictive model to automatically create changes within the warehouse environment or suggest changes for supervisor approval based on these expectations. So for example, with the expected work created by the orders available in the system, move an employee from picking to replenishment for 2 hours. And this can also be supported with that automation in the environment. So if we're bottlenecking one area of our environment, maybe our goods to person automation is being overwhelmed with orders, maybe we shift some of those to our zone 1 manual picking to alleviate some of that back pressure. And so we can leverage these AI supported trends and projections to make those automated adjustments in the system. And so these are really going to help us balance workload in the warehouse through reduced downtime and bottlenecks. And as far as warehouse execution systems, the ways that we can leverage these in our environments, let's take a look at these applications in practice. So as an example, let's consider warehouse task optimization, or what has been traditionally called task management, where the WMS is going to assign work to users automatically in the warehouse. So in previous iterations of even tier 1 WMS systems, optimization has always been based on these three things: priority, proximity, and permissions. But this is a fairly rigid rule-based structure that can actually create unnecessary travel and wasted time by simply moving down a task queue list. But by leveraging AI to determine the difference between the task queue, looking at which employee is about to finish a task based on task locations in progress and expected task completion times and locations, as well as task difficulty, instead of just those available for new work, it can better allocate tasks to reduce that unnecessary movement and improve throughput in the warehouse. Similarly, it can also create and manage priority smoothing techniques for things like carrier cutoff times. So for example, say that for our operation, effectively, it makes no difference to us whether the carrier cutoff is 6 hours away or 4 hours away. But in traditional task management frameworks, and these kind of more rigid rules-based processes, typically it would say, okay, the carrier cutoff time that's 4 hours away has a higher priority in the system, so we're going to prioritize all of those tasks. Whereas the warehouse execution system can use these AI modeling techniques to be able to smooth out that prioritization, since effectively all of it is still going to get to the carrier, whether it's 4 hours away or 6 hours away. And so can actually bucket those prioritizations so that we can more optimally select tasks for better optimization and throughput in the warehouse. And all of this is just designed to create that data-driven decision-making to automate the optimization of your warehouse. So labor is going to be optimized in this more automated function, while supervisors in warehouse management are able to spend more time on value-added activities rather than manually adjusting these work queues. And now that we've seen how AI can power kind of same-day warehouse queues adjustments to reduce those bottlenecks, we'll head into our next section. So automating labor scheduling ahead of time and day of coordination to reduce bottlenecks and administrative burden in the warehouse. So as far as labor planning, an AI copilot can use predictive modeling, so leveraging that historical information, as well as causal modeling, so looking at how the system expects work to be completed in the warehouse, to auto reassign labor resources by making intelligent suggestions to supervisors. So in this specific example, we're actually looking at the Softion WES framework. So looking at our labor orchestration to add staff to cooler picking to better balance our labor in the warehouse, but giving us this kind of holistic dashboard view of where we could smooth out our labor resources in the warehouse, and then giving that intelligent recommendation to our warehouse supervisor, who could then potentially leverage their institutional knowledge and understanding of the operation to decide whether or not to make that movement. So as an example of this, say we have two employees, Steve and Mark, that are both underutilized in their departments. So one's in cooler picking and the other one is in ambient pallet picking, respectively. So they're both cross-trained in replenishments. The system and the AI model can take in information on their cross-training, utilization, and the equipment needed to move them from one position to another, and then can select Mark as the optimal employee to use in pallet replenishment. So already on the right equipment, because he's doing pallet picking already, and therefore is on some kind of forklift that can more easily transition to pallet replenishment, the system can then even switch Mark's task queue from pallet pick to pallet replenishment. So there's no intervention needed from a supervisor in that specific example of where this industry trend is going. However, you may not always want your supervisors to not have any influence on those kinds of human labor changes in the warehouse. And so I actually think that one of the best ways to utilize AI is not necessarily to have it automate all of these processes, but really enable your warehouse management to make more data-driven decisions. So we can create these kind of tooltips and these kinds of suggestions to warehouse management without them having to dig through a data repository and do lots of SQL queries and be very reactive in terms of what's happening in the warehouse. But they can use their institutional knowledge and their understanding, their deep understanding of your operation to then decide whether or not that's actually the correct choice. Maybe there's a reason to move Steve instead of Mark to our pallet replenishment environment. And so by enabling your warehouse managers to have that better information, it creates an environment where they can have better decision-making techniques, but still leveraging their expertise. And AI can be leveraged not just for those kind of game time decisions of unexpected work shifts throughout the day, but also labor planning more generally. So this is one example of a company that it's called Tact, that is a labor management system only company. So it's a best of breed solution. And they use predictive and causal models to convert sales forecasts, client demands, and financial projects into precise labor plans, leveraging historical data with causal expectations. And they do these plans also for both direct and indirect labor. So if anyone is unfamiliar with that terminology, direct labor is more for traditional warehouse productivity. So things like picking tasks and put away tasks. Indirect labor are still things that need to get done, but don't necessarily directly contribute to throughput. So things like changing out your forklift battery or doing cleaning or a safety meeting, et cetera. And so TAC can actually leverage its AI modeling to even build in those indirect tasks into the plans and use that to hit targets associated with either quantity or hours needed for throughput to drive that greater performance and efficiency in the warehouse. And then beyond kind of setting up this plan ahead of time, they then also use that modeling to continue to monitor whether it needs to make adjustments to that initial forecasted plan. So not only is it integrating those real-time insights and historical trends with AI computational structures to streamline your workforce management and achieve your assigned operational goals, but it's actually then leveraging that information and comparing it to other aspects of your plan to make sure that you can stay ahead of potential issues. So using both that forecasted information to build out your labor plan ahead of time, but then also making the necessary same-day adjustments to make sure that you're achieving your optimal throughput. And now that we've seen how AI can create data-driven labor plans to optimize your workforce, both with pre-planned schedules and with same-day workflow modifications, we'll head to our last section. So specifically looking at leveraging AI for employee performance reporting, both in terms of additional statistics we can leverage, but then also for some more of those soft skills functions, as well as getting better data-driven insights on employee safety, as well as performance to create a happier, healthier, and therefore more productive workforce. So in supervisor coaching, we can actually combine several different AI models to improve this structure to get the most out of employees. So as an example, say we have an employee that has been falling below expectations in cluster picking. So by leveraging our causal model, where we're doing that root cause analysis, maybe we determine that Stephanie hadn't been trained well enough, and or if we give her additional training, then she will likely come up to standard. And so it may then recommend that we retrain Stephanie on cluster picking. But then if we combine that with our predictive modeling, we can see trends of maybe previous employees that have been retrained to come back up to standard. We can determine that if we retrain Stephanie, then maybe we'll need half a person less staffed in that cluster picking area for next month's expected order volume. And so by getting this level of information, we can also, as warehouse management, make more effective and intelligent determinations, such as whether it's worth it to us to retrain Stephanie. Maybe we just staff her in areas where she's more effective because we're in peak and we don't have the time to lose her to do the retraining process, or maybe we're going into peak and so we actually need to complete this retraining earlier rather than later to make sure that we're ready for our peak times. And then finally, we can even leverage generative AI for better soft skills coaching of our supervisors. So in a previous role, I ran a warehousing staff of 75 people, and a common issue with our supervising staff is that they would come back from feedback conversations and their comments, their reporting from it, would be things like, would basically be saying, oh yeah, this person is falling below standards, told them they were falling below standards, versus we can use generative AI to have more productive coaching conversations, structure feedback with more quantitative elements, make it more constructive, try to make it soften the language so that these are less combative conversations. Lots of different things we can do to actually coach our supervisors so that they are managing their teams better and creating a happier, more effective workforce. So coming back to our LMS company, Tact, in a real world example of using some of this AI modeling for these supervisor coaching aspects. So traditional LMS really just gives us this information, which is how is our employee measuring against standards, and their utilization in their environments. So this is absolutely useful information to have from a traditional LMS perspective, and it can be reported on in lots of different ways and dashboarded in lots of different ways. But AI can really supplement this information in a few ways to help support our warehouse employees better, by enabling our supervisors to have more complete information over their capabilities and how to best coach them going forward. So in Tact, this takes the form of this AI coach structure. So vast amounts of data are coming into and from the WMS on a day-to-day basis, but interpreting this vast amount of data is difficult, right? It takes that real-time decision-making skill and experience to be able to really break down that data into actionable insights. And so here, you're really just having AI do that legwork for you. So creating those actionable insights for your team to actually leverage in their day-to-day management without having all of that, that labor up front. So it's allowing us to integrate advanced warehouse intelligence and analytics and empower employees to make more informed decisions that are going to enhance operational efficiency and drive that continuous improvement. So for example, this is showing us how employees are tracking against other employees in their in the areas in which they're working. And so we can also see how they're tracking against their peers at a high level. And then this can even be translated into this coach to take it a step further. So specifically giving kudos to employees that are doing well as constructive feedback. And I actually really like this function from Tact, because I think that this is also something that often gets forgotten in warehouse supervising environments, where we often spend so much of our time focused on the low performers and bringing them up to standard that we don't always give the positive reinforcement to our high performers, which is something that has been seen to improve retention and maintain high levels of accomplishment for employees, is basically by just giving recognition to high performers. And so I also like that you can have these data-driven discussions in terms of positive feedback as well as constructive feedback. And this is all leveraging those predictive causal AI models, and then pairing them. They can then be paired with generative AI for the suggested feedback conversations that can leverage this kind of data-driven insight to have in those conversations, but again, with modifications to the language and the ways in which we're framing this feedback from supervisors to employees. So there's multiple layers here to providing information to be more effective supervisors without having to scour through and analyze data, but in a way that the AI model is really presenting your supervisors with this information for those more effective conversations. So our last AI type that we'll look at in today's presentation is vision AI. So that translation of photograph or camera information into usable data. So our first example is going to be a company called Macondo Vision. And this company really uses AI to translate employee movements into data tracking. So they're tracking each individual employee, which tasks they're completing, their rate of task completion, and the individual items involved in each task. This one to me, honestly, is a little bit creepy. I think it's really cool. It has a lot of really interesting applications, but it is a little, I mean, it's the futuristic element of being able to track everything so granularly just from that camera information. But basically, AI is going to AI enables the action recognition of each specific movement, and these recognized actions are categorized and tagged for reporting. So captured actions are going to be often used in combination with other AI modeling like predictive and causal modeling to determine gaps between optimal performance and actual activities. So things like recommendations for retraining, seeing when employees are employing faster or slower methods of task completion, and can even make ergonomics recommendations. So such as when a floor mat is creating a trip hazard. So that really enables you to protect employees while giving more complete information over your workforce. And paired with additional AI modeling, such as performance coaching, structures that we just reviewed in our previous slide with TACT, this can also give your employees more effective support in doing their job well. But beyond Macondo Vision, speaking of ergonomics and safety recommendations, there is a company called Voxel AI that fully focuses on warehouse safety. So their system and their AI modeling actually does not include any kind of performance tracking. It is all geared towards improving safety. They're actually able to leverage pre-existing camera frameworks in traditional warehouses. And they basically use this with their AI algorithm processes to determine potential hazards and safety violations. And they've actually seen some pretty staggering results with this main focus on safety. So they have companies with 77% reductions in injuries, 92% reduction in vehicle incidents, and then across the board, they've seen a 55% drop in general safety incidents and a 70% drop in safety line incidents involving employees. So again, a safe workforce means a healthy workforce, and AI can really help drive safety programs to reduce the number of injuries and safety incidents, meaning less time missed for our employees and also a more productive workforce. And speaking of a fun little Easter egg, and one reason we might want to leverage this kind of visual AI. So in the banner for today's webinar that got sent out in our email communication, there are actually several safety violations that could be caught and corrected for by vision AI companies like Voxel and Macondo Vision. So for example, this employee is standing on an electric straddle stacker or walkie stacker. That's not a machine that you should be standing on. So definitely improper usage could definitely cause an injury. He's not wearing a hard hat, no high vis vest. So definitely some safety modifications that we could make with our employee to make sure that he isn't injured through this improper use of his equipment. And for those who didn't catch that, maybe worth looking into Macondo and Voxel more closely. Okay, so in conclusion, I want you all to envision your warehouse of tomorrow. So bringing AI into warehouse labor management isn't just about automation, but about empowerment. So from a warehouse execution system perspective, it doesn't replace human decision-making, it really enhances it. It's really designed to allow your managers to make data-driven decisions with unprecedented precision and confidence. Then in terms of our predictive analytics, it really transforms scheduling in your labor management from reactive to proactive. So imagine starting each day knowing exactly how to deploy your warehouse for maximum efficiency, with AI then fine-tuning those recommendations based on real-world data. And perhaps most exciting, how AI-driven performance management is revolutionizing employee development. So by identifying opportunities for improvement and delivering targeted training recommendations, we're creating a workforce that's not just managed, but continuously evolving and improving. So the future of warehouse labor management isn't about choosing between human expertise and AI. It's about creating a powerful synergy between the two. So by embracing these AI tools, you're not just optimizing your operations, you're investing in your people, enhancing their capabilities, and in building a more resilient and adaptive workforce. All right. Thank you all so much for attending today's session on AI and warehousing labor management. I really appreciate you all taking the time to walk through this kind of industry review with me. So we'll open it up to a Q&A. As Faraz mentioned at the beginning of today's session, please enter any information, any questions you have in the chat, and we'll kind of start going through a few things, but also feel free to reach out about more. If you have any additional questions we don't cover in today's presentation, please feel free to reach out to me, reach out to our managing director of our Australia office, or look for more on our website. So thank you all so much again for taking the time.
Thanks, Paige. It was very insightful and interesting presentation.
Thank you.
Oh.
I just saw in the chat the Melbourne. I'll work on my pronunciation.
Yeah. Here we go, the question coming.
All right. Softan. So how is Softan integrated in the workplace? So Softan is a warehouse management system vendor. And so it is a browser-based, cloud-based product. So available anywhere at any time from any modern browser. But we are highly adept at working with third-party software. So that's actually, for anyone who's familiar with analysts, we're often in the Gartner report for WMS software. And one thing that we are consistently touted for is our ability to integrate with third-party systems. And that in turn includes third-party softwares as well as material handling equipment. And our warehouse management system actually has a warehouse execution system embedded in it. So it's part of our baseline offering, as well as it can work with third-party WMSs if you need a layer on top to orchestrate labor and material handling equipment. So in terms of, I think Brian asked which WMS that we integrate with. So Softan actually is a warehouse management system. So we do have some labor management system functionality, but for some of the more advanced AI-driven structures we reviewed today, Tact is actually one of our partners. And so we integrate with them, as well as EasyMetrics and TZA are our kind of three main labor partners that we integrate with. But the warehouse execution system that has some of that smoothing of warehouse management that leverages some of those AI models is embedded in our warehouse management system offering. So that doesn't require any additional integration as part of the same platform. And then what else do we have? How can AI be used to support? Joseph asked, how can AI be used to support rostering and rotation of tasks? So that's going to be part of that warehouse execution system function, where basically the orchestration layer can leverage can use the causal and predictive modeling for the creation of those trends and projections that can basically reprioritize work in the task queue. So that's typically how AI can be moved into those systems. It's going to project out, if this task is done first, how is that going to domino affect the rest of the work that I have available in the warehouse? And depending on how advanced the model is that the software that you're using is leveraging, it can then make those kind of more automated or informed decisions about making adjustments to the task queue. And then, okay, let's see. What VLMs have we had experience integrating with? I can actually take that one as a follow-up. We're pretty vendor agnostic. We actually have a pretty robust framework for integrating with various material handling equipment vendors, and we do have a vendor agnostic structure, but we do have experience with a wide variety of VLM automation vendors. But I can get that and take that as a follow-up. Okay. And then Daniel asked, is Softion's AI model trained on local Australian work rules and laws? So it is not strictly trained on local Australian work rules and laws, but it's not necessarily needed because the WES is going to use the standards and information that are currently available in the system. So if things are not disallowed, you can also put that as part of the modeling. So basically we can make adjustments on an implementation basis, but a lot of the time specific work rules and laws will kind of be built into the planning more than they will impact the prioritization of the task queue. Okay. And then Bill asked, one of the biggest challenges facing warehouse managers is the fast turnover of staff like pickers and associated high training costs every year. Does Softion provide the functionality of giving insights about the labor utilization and planning and their association with staff job quitting and turnover rates? So Softion specifically does not really look at turnover rates. We can define custom reporting to do that, but that's really more of a workforce planning module. So I would actually recommend like an HCM, so like a human resource system or a workplace planning module, which kind of is more about staffing and turnover. However, it will give insights on labor utilization and efficiency as part of the baseline labor system. Okay, and then Virgil asked, what's the average payback period for investing in the system? So again, the system being a couple of different things. So the information that we went over in today's presentation was kind of several different companies that are in the industry. This presentation is really more of an industry review and like where it's going with the trends in AI and the incorporation of AI and new technology into labor management, more than it is the Softion WMS, which is the product, the company that I work for. And so it really depends on what you're deploying in your environment, whether you're leveraging TACT and you're doing more supervisor coaching and forecasted labor planning, whether you're using a WES to smooth and orchestrate human labor and automation to have faster throughput for both. It really depends on what kind of AI applications you're using in your environment. Okay. Frederick asked, what type of reporting is available? Dashboards. So again, it depends on what labor system you're using. As far as the Softion WMS, so the Softion WMS does have a full suite of reporting. So it has a full suite of standard reports as well as dashboards, and it also has a lot of self-service capability to define custom reporting as well as custom dashboards. So there's a lot of flexibility in terms of how you want to interact with the information in your system. And then again, it will really depend as far as the different companies that we went through over today's presentation. pretty much all of them will come with some kind of reporting and dashboarding. But again, it just depends on what you're looking for. If you're piping out any of the data to an external BI tool or data warehouse, how you're structuring your data reporting and kind of what you're looking for and leveraging these systems. And then Brian asked, have you had any Australian customers to date? So yes, the Softian WMS is deployed in several facilities in Australia, admittedly mostly with global HQs, so not HQs in Australia, but we have several 3PL customers, including a company called TDLC, which is a 3PL based out of Sydney, as well as UPS is actually one of our largest customers. We're deployed in many UPS facilities globally. They're actually transitioning all of their facilities over to Softian WMS by the end of 2025. And so all of their facilities in Australia are also Softian WMS.
Okay, Paige, we have 2 questions in the Q&A section.
Sure.
What
What you got?
Yeah, Gus asked, is this functionality separate to the WMS components in Softian, procured separately, question mark?
Yes, so the WES that we looked at today is part of the Softian WMS system, and so that's part of the baseline product offering. The other functionality that we looked at today, so in terms of Tact, Macondo Vision, and Voxel, those are separate companies, and so they would be priced separately. So again, it just depends on what you're looking to deploy.
And then Peter asked, do you have any Softian case studies on this AI and labor capabilities that can be shared?
I actually don't know. We can get back to you on that kind of case study information. I can also, I can also recommend some of the companies that we walked through today. So specifically around Tact and Voxel and some of those. I know that they also have case studies on their website of deploying these AI-driven methods in warehousing. Okay. Oh, I just realized we're a couple minutes over. So I know that there are a couple more questions in the chat. So maybe I'll just do these last 2 in the chat, and then we can call it if that works for everyone. Okay, so Peter asked, how feasible is it to apply this AI solution or these AI solutions into a mature warehouse operation? I actually think that it is a good time to do that. I think that a lot of these solutions pull data from pre-existing warehousing software and then are able to translate that into actionable insights, right? So if you didn't want to do a full WMS transformation, for example, you could use Tact to just pull data from whatever system you have to get you those actionable insights, and you would just define the integration, but it would just create all of those the insights and planning and data-driven information based on the information fed from your pre-existing WMS. And Voxel can use pre-existing cameras that already exist if you have any kind of security camera network in your warehouse. So I think there's a lot that you can leverage in pre-existing systems. And I mean, even with the Softian WMS, well, if you did want to do a full rip and replace, please definitely come talk to us about a new warehouse management system. But then we can also deploy our warehouse execution system on top of any pre-existing WMS. And so that AI-driven process can absolutely be integrated into a pre-existing WMS framework. And I think that AI is a way to really get gains in your warehouse, your more mature warehousing environment, for optimization purposes. Okay, and then my last question I have in the chat is Bill asked, does Softian have the functionality of suggesting optimal walking/traveling routes for pickers? So yeah, in the Softian WMS, we absolutely do optimize pick routes. So that's part of the waving logic. We do wave and waveless processing, but the logic for the task creation and leveraging those task capacities is leveraging ideal pick paths through the warehouse. So you absolutely have optimization associated with travel time. And also we have structures associated with task interleaving to also fine tune whether you're prioritizing things that have been highly escalated versus things that have started that prioritization level, or if you're more highly prioritizing optimizing travel path or reducing walking versus prioritization. So we have a lot of flexibility and granularity in terms of defining that kind of optimization in your system. Okay. So, one more from Bill is in performance reporting aspect, do we allow reporting the picking damages to products of staff? So yeah, you can absolutely report damages and have that be part of your standard reporting in the WMS or in some of these labor management functions. That can actually absolutely be an aspect that you track as part of your system. Okay.
Perfect.
I know we went a little over, but thank you all so much for your time.
Thanks, Paige. And this is our first webinar with Softtune. Hopefully, we will have more during this year. And the webinar is recorded and will be available after this. Thanks again, Paige, for your time and the presentation.
Yeah, thank you.
Bye, everyone.
Bye, everyone.